Hi guys, and welcome to this Houdini tutorial. Today we're going to be looking at how to create attributes on our objects and utilize that by painting into our custom attributes and use that for modeling purposes. So it's really powerful. So what we're going to have a quick look at is by generating some content in here. So I have a fresh Houdini scene, and I'm going to create some geometry by hitting tab and typing in geometry into my node tree and hit enter to generate that node. Press I to go inside of that particular geometry node and delete out the file node. Next we're going to generate a grid, and again it's hitting tab to bring up the node generator menu, and we'll zoom out. I'm going to use my trick again of making sure that rows and columns stay uniform by copying the rows parameter by right mouse button clicking and saying copy parameter, and then right mouse button on the columns parameter and saying paste relative references. Again, this creates an expression, a channel expression, which is saying return the value in the rows parameter. So now they are both linked together. I'm actually just going to add some divisions, maybe 100 divisions for this particular grid itself. Next we need some attributes to assign to this particular mesh. What we did look at in the previous video, the copy stamping video, if you haven't watched it, is the ability to have a look at the geometry. This has actually been a set, so sorry, I'm just set an ortho by accident. There you go, perspective. So in the geometry spreadsheet, you'll see that here is all of every single point assigned to this particular node, and its positional data, which is a p attribute of x, y, and z. And you can see that has been kind of supplied to us itself. If you need to take a look at all of the point numbers, you can see that we have a huge amount of points, and if you want to zoom in, there's all of the point numbers themselves. It can be overwhelming at once sometimes, so let's turn that back off again. Next we need to generate our own custom attributes. So we're going to type tab and then go to a point node, and we're going to hook up the first kind of input itself and visualize the node. Here again it's generally dealing with the point position at the minute, and it says return itself, but we want to change that to something else to kind of simplify things. So it can show you color, and rather than return itself, we can say return a constant value, and we can change the value to anything that we want. So if we wanted to have more of a kind of bluish color, that would return that instead. And again, if you go to our geometry spreadsheet, you can see that all of our points now have a brand new attribute, which is CD, or color diffuse, which is broken out into the R, G, and B components of that particular color. And again, you can see that here in the breakdown, 0.121, 0.318, and 1. And that is entirely the same for all of those particular points. Other particular values are very similar, is that instead of returning a given value, you could say return random values on every single point, and now we have random color for every single point data. This at elem_num just means the number of the element that you're currently generating data for, and you can see that the attribute class has been set to points. So if we were to change that to primitives, you'll see that every single face now has a different piece of color data attached to it. So it is good to know what you're working with, because that at elem_num attribute will become quite important. But we're just going to work with points. And instead of having that random value, we'll have a constant value. Now, I don't generally want to work with color just yet. We're going to create our own custom attribute, and instead of it being CD, we're actually going to set this to density. And again, at the minute it's thinking that it's a type of color, I'm actually going to change that to a vector type and keep everything to 0. So again, if you want to check what you're particularly doing, you can go to your geometry spreadsheet and see that we do have a point. So there's points data. So it's a point attribute. This is called density. So it's called density, and it's all been set to a value of 0, 0, 0. Now, what we can actually do is now start to paint values into density using a paint node that would generally be used to color a piece of geometry. But the paint node actually has a really nice override for color. So if we toggle on override color, and rather it being the CD attribute, we actually want to set that to that density attribute. So whatever you've named the attribute here, it has to be the same in the paint node. And if we were to activate the paint node, sometimes it doesn't always do it, so hit escape and then hit enter to activate the tool. With that particular node selected, you'll see that we have a paintbrush icon kind of here. And if you want to make the paintbrush bigger, you can hold down Shift and left mouse button, click and drag, and that will allow you to paint data into that attribute. So if we go back to our spreadsheet, you'll see that although it looks like all of these are still 0, if I click on density, it will sort by value, and you can see that a lot of density now has value of 1 and will range between those particular values all the way back down to 0 again, based on what we're actually painting. Now, why would we actually want to do that? Well, the next stage is again accessing very specific pieces of data. We're going to drop down what's called a scatter node. Now, a scatter node allows you to scatter points across any given surface that is plugged into. However, one part of that, so you can see it is just taken every part of the grid and scattered points on it. So one part of that is that you can utilize attributes to tell where the point should be scattered into. And it just so happens that the density attribute is called density. If we'd named this point attribute anything else, for instance B, there we go, just B, our paint attribute would have to be called also B. And then for the scatter node to work, we would also have to call that density attribute B. So all three would have to be exactly the same. Our paint node has kind of gone out the window because it has reset our painting. So if we kind of repaint back into that and go back to our scatter, you can see that it's picking up that data as to where to scatter all of those particular points. We also have a control over how many points to scatter and how relaxed their spacing is, which is governed by these relax iterations. So you can always kind of make them clump a bit more or anything along those kind of lines. So these are now a specific area of that geometry where I want to have points in, and we can utilize our knowledge from the copy node or the copy stamping node as well to copy objects onto those points. So for instance, I can use a copy to points node, and we're going to use an L system node. Now, an L system is quite complex, but its base structure looks very much like a tree, which allows me to generate basically a forest in next to no time. And again, this is entirely customizable based on where I paint the density attribute. Now you can see that the placement of all all of these particular trees randomizes as soon as I paint any additional information, because it's scattering however many copies within that given texture or within those given values. So as soon as you change those values, it's changing where it's placing those particular trees. You saw there that I quickly changed to the background, and that's middle mouse button clicking and dragging, and that kind of minuses away, so it paints the background color, or left mouse button will paint the foreground color, so black and white basically. So you can see that I have the ability to manipulate where this forest is actually being generated. And then again, going back to my scatter node, I can change the density of that forest. And then on the L system side, we could maybe drop in a transform node and then change how large those trees actually are. So there's a lot there that we can have control on. Again, artistic control that would be incredibly difficult to get in any other package. At the minute, we only have our trees because that's what the copy to points does. However, if we drop down a merge node, we can take those particular trees and merge them back together again with the initial grid node itself. And you can see that both of these will be displayed to us when we visualize our final node. These L systems are infinitely thin at the minute. They're almost just polygon edges. So what we can do is drop down a poly wire node, which will give us thickness and polygons around those particular trees. You can see it's a bit crazy to begin with, but as soon as we start to drop down our wire radius, you can start to see that we are getting proper geometry for these particular trees. And again, if you were to use the copy stamp node, you would be able to start to randomize not only the size of these trees, the rotation of them, but the overall generation of these L system trees. So it's again a really useful way of working. So this is a really super quick overview of how to paint values into custom created attributes on meshes. So thanks for watching. We'll actually have a look more at attributes next. Thanks.